Hello, I'm Andrew Ingram.
And I'm Greg Arhart.
This image shows the basic outline for an AC to DC converter. The symbol on the far left symbolizes a transformer, but since we were just working with the function generators in the lab, we do not have one hooked up to the circuit. The cluster of symbols on the right is the rectifier, which is composed of resistors and diodes. The branching in the rectifier is what allows the LEDs to remain illuminated rather than having just one branch on or the other. When an AC source comes in, it consists of positive and negative voltages. Since diodes are PN semiconductors that allow the flow of current only one way, the polarity of the diodes and the polarity of the signal must be the same in order to get light. The orientation of the diodes in the branches creates an always positive voltage. This enables the LEDs to light up without flickering. This image, blurry as it may be, is our schematic. We wired 10 LEDs in parallel with a 100 microfarad capacitor. The LEDs are spread out over 5 branches with 2 in series on each branch. The reason we did this was to provide equal resistance across all 5 branches. And a resistor is no longer needed because the internal resistance in the LEDs is sufficient enough.
Alright, so this is the rectifier for Lab 5. The rectifier basically is what we're using to take the AC voltage and convert it to DC. That way we can then take the voltage drop from here on the rectifier and bring it down to the LEDs down here. And because that's now DC voltage, we can then power our 10 LEDs. Okay. We decided to do 5 pairs of 2 LEDs in series, as it would have equal resistance across all branches. We had issues when we tried any other numbers due to the least resistance. The least number of LEDs would be lighting up.
As mentioned earlier, we had issues with running groups of more than 2 LEDs in parallel. In this, you can see we have 3 here and 3 here versus the 2 on each branch here and here. And so, when we run it, the current takes the path of least resistance and fully ignores the clusters of 3, only going through the clusters of 2.
Here we have our final design on some perforated circuit board. Although it was extra credit, the design was simple enough to implement with ease, so we went ahead and did it anyway. While this image does not show the LEDs illuminated, the implementation actually does work. The packaging, also not pictured, was a simple cardboard enclosure that was hot glued together somewhat crudely. On the left side, you can see the rectifier, which is wired up to the bulk of the circuit. The 100 microfarad capacitor is wired in parallel with the LEDs, as indicated by the schematic. And you can see the LEDs were wired and soldered in the same layout from the schematic, that being 5 branches with each containing 2 LEDs in series.